Hey everyone! In this video we are going to be solving unknown sides in right angle triangles. And we're going to be using the three trig ratios, sine, cos, and tan. Now our three equations are over at the side, but there's actually a little mnemonic device that we can use to help us remember these little equations if you don't have them provided to you. And that is called SOH CAH TOA. And what that stands for is sine uses the opposite over the hypotenuse, cos uses the adjacent over the hypotenuse, and tan uses the opposite over the adjacent. SOH CAH TOA. And if that helps you remember them, hooray! That'll be great on you. In this video, we're going to be practicing solving sides, which means one of the angles has to be provided in addition to the right angle. So we're just going to go ahead and label this triangle, put a 40-degree down there, and we're going to label our hypotenuse as 20, and chuck an unknown x over here. Challenge 1, which of the three trig ratios do we use? By looking at this triangle, we can see that we have an angle. Hada! That's our theta. We can see that we have the hypotenuse given to us, so we know we're using one of the equations that uses the hypotenuse. And we're looking for x. In this case, x is our opposite. We have the opposite side and the hypotenuse. We'll notice that the adjacent is not involved. The only trig ratio that uses the opposite and the hypotenuse is sine. So we can write our equation. Sine, we know what theta is. It's 40 degrees. This is going to equal our opposite side, x, over our hypotenuse, 20. We can go ahead and put sine 40 right into the calculator. Make sure you're in degree mode. Oh, so many people get stuck in radians, and that's not good for you. We can go ahead and put that in, and you get 0.6428 equals x over 20. In order to get this x, we're going to multiply both sides by 20. When we multiply both sides by 20, that's going to cancel the 20s over here, and it leaves us with x equals 12.86. And that's all there is to solving that. The biggest challenge was actually realizing that you needed to use the sine ratio to begin with. Let's go ahead and throw another one up here. This new triangle, theta stays in the exact same corner. We have a 55 degrees in the bottom right-hand corner. We still have our hypotenuse, but this time it's an x, and we still have our opposite, but this time it's the known number. Once again, we're not worrying about the adjacent, so we know that it can't be cos, can't be tan, we're using sine. But it's going to set up slightly differently. Let's take a look at this. We have the sine of 55 degrees, that's the same. It's going to equal our opposite side, which is 15, over our hypotenuse, which is x. As always, you can go straight to your calculator and convert that sine 55 into a number. That's just an operation on a calculator. And it's going to be 0.8192 is equal to 15 over x. In order to get rid of an x on the bottom, we're going to use some healthy algebra, and we are going to multiply both sides by x. Yes, there are some little sneaky tricks to do this, but this is the safe way to do it. It's good for higher math too, and we end up with 0.8192x equals 15, at which point this is a nice little algebra problem. We can divide both our left and our right by 0.8192, and we are left with our final answer of x equals 18.31. Of the two ways to solve it, those are the two types. Your unknown is either going to be on the top of the fraction or the bottom of the fraction. And I'm just going to work through two more examples if you needed to see them, and otherwise, hooray if you can go solve them on your own, but we're going to work through two more examples here now. In this triangle, we can see that we're no longer working with the hypotenuse. If you looked at the last video on trying to decide when to use sine, cos, and tan, we know that if we don't have the hypotenuse, the only two sides we're working with are the opposite and the side that connects our angle to the right angle, our adjacent. That means we have to be using tan. Our equation is going to look like this. the tan of 25 degrees equals our opposite side, in this case x, divided by our adjacent side, in this case 20. We can head straight to our calculator, turn that tan 25 into a number, 0.4663 equals x over 20. And if you're comfortable with your calculator, you can just take that answer and multiply it directly by 20. You don't have to write it out. I'm just trying to show my steps to help you out here. We multiply both sides by 20, which means we're going to multiply this by 20 and this by 20, and right away we get our answer, x equals 9.33. This is another example of when our unknown was on the top. We simply have to do our trig operation in our calculator and multiply by the number that's on the bottom. One more example to finish this off. And our last triangle. Hey, look, he moved theta up top. I got told that I should keep scrambling these questions up so that we can see all the different little variations your teacher could give you. So oftentimes we look at one set of examples, and then if we change the triangle, it becomes totally different. But in this case, just because theta moved, the angle that we're looking at, we can still solve this. X is still the hypotenuse. Hypotenuse doesn't change, it's always across from our right angle. But this side, which used to be our opposite, is no longer our opposite, because now it's the side that connects our angle to our right angle. This is now our adjacent. We're looking at our adjacent and our hypotenuse, which means this is a cos. Let's write this out and see what it looks like. We have the cos of 50 degrees, and it's going to equal our adjacent side, which is 30, divided by our hypotenuse, which is x. Again, go to the calculator. That cos of 50, that's just a number. You don't have to be afraid of that. 0.6428 is equal to 30 over x. The good little algebra way, make me proud, multiply both sides by x. That's showing your work. You'll see that the x's on this side cancel out, and it leaves us with 0.6428x equals 30, at which point we can divide both sides by 0.6428. 0.6428. It cancels on this side, and it leaves us with our final answer of x equals 46.67. Those are the two different ways that we can solve these problems. I hope that that was helpful. We tried to do a mix of sine, cos, and tan. In the next video, we are going to be looking at how we can solve unknown angles when we're given both sides. I hope this was helpful, and enjoy some practice.